Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and this is Nikolay, founder of Postgres AI. Hey Nikolay, how's it going?
Everything is all right. How are you?
Yeah, good, thank you. It's been a nice sunny week here in the UK.
Oh, this is who stole our sun. Okay.
So this week we got a listener request. In fact, we get quite a lot of listener requests. Thank you, everybody. This one was from Sharon Mukherjee. Apologies for pronunciation. And they asked us about synchronous commit and whether or when it might make sense to ever turn it off or use different settings. And I thought it was an interesting topic, full stop. So I wanted to get your thoughts as well on this.
I have many thoughts on this. We need to start somewhere. So
I wondered about starting probably not in the most obvious place, but on a single node setup. I know this becomes more interesting multi-node, but on single node, pure Postgres, there are still some interesting discussion points here, right?
Yeah, and even before that, there is single. So the meaning of synchronous commit is overloaded. I know, like technically, it defines behavior of commit, right? And there is local behavior, and if we have synchronous standbys, there is remote behavior. But originally, it was only about local.
Yeah.
And then decision was it was only on and off, two options. This is how I remember it for a decade or more than a decade of being Postgres user. And then there is overloaded meaning. Remote apply, remote...
right.
Yeah, remote write, remote apply. Two options. So I think my first thought is it's a huge mistake to mix things here. It causes pain in users like me. All the time I read it, like I cannot remember this. To remember this, you need to deal only with this,
Yeah. Or well, you can't remember it. You just look it up I just look it up
every time you look it up and try to understand the logic. It's like we have many places in GUC system, Postgres system like this. Like for example, we still do a lot of consulting. We help our customers. Many of them are startup companies who grow rapidly. Very smart people. They understand things very quickly, but you need to explain what's happening. And one of the things, like we deal with bloat all the time. Like bloat is one of the major concerns. And we explain, okay, we need auto vacuum tuning. And there is auto vacuum work mem, which is -1. It means you need to look at maintenance work mem. Why was this done? This is exactly the same thing. Like, why was this done to my brain? Like, somebody made some decision to cause huge pain for ages. It's a UX issue, like a user experience issue, because instead of clarifying and separating things, we develop some implicit dependencies, and you need to be expert. And even if you are expert, it's really hard to memorize all these things. And the problem is, like, at some point we will use more and more AI and so on. But to explain these things to AI, it's also difficult because there are implicit dependencies. So synchronous commit can be local, but it also can be not local. And local is on and off, and there is also word local, right?
Yep.
So meaning of on was rewritten. Thank you, guys. Thank you who did this. Thank you. Like, to explain, like, if you try to be a consultant and explain things to others, very smart guys, you will see the pain. It's really hard. And why is this hard? This is my first thought. Why is this so hard?
As you say, it's because it's combining two things, right? And the behavior is... I can see why they combined it though. Like the behavior,
I also can see. No questions here.
And to their credit, the documentation is really nicely written. So
okay,
it can be pointed.
It's nicely written, but it doesn't explain all the things. So I hope
Okay.
We will touch additional topics not covered by documentation today.
Nice.
Yeah.
So let's talk about the case, single node case, on, off, on by default, right? So like, why would we want to turn it off? What's happening here?
Yeah, if we forget about multi-node setups, we have just one node, right? And if we have write-heavy workloads and we think write latency is not good, and eventually write throughput is not good, right? Because if latency is not good, throughput won't be good as well. Right? There is some dependency there, which is not straightforward, but there is. And it means that, well, we know at commit time, Postgres needs to make sure information is written to wall and it's present, like synchronized to, like it's on disk, right? So we need, before that, Postgres cannot respond to the user that commit was successful. And when we say commit, it can be explicit commit or it can be implicit commit if we have a single statement transaction, which is super popular approach in web and mobile apps. So when we just have single statement transactions all the time, just separate and so separate update and so on, and all of them have implicit commit as well. So commit can be successful only when wall is already on disk. And it means we need to wait for disk. And if disk is not a RAMFS, which is in 99.99% of cases, right? If it's regular disk, it can be quite slow. And in this case, we deal with like if our transactions are super fast, like extremely fast, which is actually rare. Usually they are not so fast because of various cases, various things, like including, for example, index write amplification. I have mood to criticize Postgres today, like, yeah, you know me.
Well,
right?
yeah. So I feel like so far you've so far described the kind of synchronous commit equals on case.
It's
so
default,
where we have to wait,
yeah.
yes, which is default, and we're waiting for the flush to happen, so the writes to disk, before confirming back to the client that commit has been successful.
Yeah.
But turning it off, we don't wait for the extra step of flushing to disk before confirming to the client, which sounds risky. Well, the risk is if there happens to be a crash on the node in the time between the write-ahead log being written and the flush, so the commit being confirmed and the flush to disk, we lose any of that data. So the risk here is some data loss on crash.
Yeah, the short like tail of wall is lost. Postgres will still reach consistency, all good, but we lose some part of data. It's similar to any multi-node setup with a synchronous node when failover happens, and if standbys are asynchronous, nobody guarantees that at failover everything will be present there, right? Because it's asynchronous.
Yeah.
There can be lags, but there is consistency, all good, and we can lose, for example, by default in Patroni settings. As I remember, there's a setting, I always forget the name, but setting like maximum lag allowed at failover. And as I remember, by default, it's 1 megabyte. So up to 1 megabyte is okay to lose. Here it's similar. There is no threshold, like unlimited, but technically cannot be huge.
I looked into it, and there is the default setting. There's a write-ahead log writer delay of 200 milliseconds by default. And so I thought maybe only 200 milliseconds worth of writes could be lost, but in the documentation it said actually yes, good point. Actually, it's for implementation detail reasons, it's about 3 times. It says it's 3 times that. So by default, it's 600 milliseconds that could be lost. Yeah. But you could reduce that. If this setting only makes sense to change if you're setting synchronous commit for any of your transactions. Yeah. But you can reduce it if you want. So you could, if you do decide to go for some use of synchronous commit equals off, then this is a setting you could reduce to minimize data loss. But at that point, you're still losing some data, or you might still be losing some data. So I'm not sure if it matters that much.
Right. So maximum is 3 times of that wall writer delay, right? And the question is, like, should we consider this? My answer is, if writes are super fast, then maybe yes. Right? If you like, there is a trade-off here, right? Obviously.
I was thinking about it in our last episode on about time series data, but you made a really good point about if you are writing kind of lots and lots of little writes. Often in time series workloads, people suggest actually batching inserts. So
of course,
by that point, so batching makes a load of sense for optimization.
It's a good point. So choosing between synchronous commit off and batching, you just choose batching.
Yeah, so but then at that point, your transactions are not that fast because you're batching maybe 1,000 or more of them together, and then the benefits of synchronous commit equals off of much smaller. Yeah, exactly. So it's I don't think you can get the benefit twice, if that makes sense. You don't get any extra benefit of doing both. Yeah.
Single row inserts versus one insert of 1,000 rows. 1,000 inserts versus 1,000 row single insert. Of course, you'll have just one commit. It's great, and it will be faster. But of course, or updates, for example. Of course, you should avoid huge batches because they have also downsides, like longer lasting locks, or a bit, if such batch is crashed, you lose more. You need to retry more, right? Instead of losing just one insert, you're losing all 1,000 inserts. So as usual, batching, my rule of thumb is just to choose batch size, so it's roughly like 1 or 2 seconds maximum, to avoid long-lasting locks and risks to repeat too much. In this case, it's great. Like in this case, just 1 commit per second, or maybe 10 commits per second. It's very low number. So in this case, the overhead of the need to wait for a wall to be synced to disk is super low, which is like roughly, you can think about it like not more than 1 millisecond. Right? In this case, like, just forget about it. Synchronous commit off is not a good idea. That's it.
Yeah.
But usually things are much more complicated because we just consider the like one type of workload. Any project has many types of workload, right?
Yeah, and that's a good point that Sharon actually made in a follow-up post that I think sometimes gets missed in this topic, which is that it can be set on a per transaction basis or per session basis, or per user basis. So if you're doing like a one-off migration or a bulk load of data and you can't for some reason batch, then maybe it's worth considering turning it off just for that user or for that session or per transaction.
What kind of situation could it be if you cannot bulk but not?
I was struggling to think of it. Maybe some streaming, like streaming case, but it felt tenuous.
If technically it comes from many sources.
Exactly.
Instead of saying, okay, we need Kafka before it comes to Postgres, and then when we will batch, it's heavy solution. Maybe indeed this is exactly the case when it's worth considering off, right? Yeah. To use off.
The other thing I was thinking about is whether this comes up as a thought for people because of tools like PG Bench, that by default you get a lot of small transactions, a lot of small, very fast transactions. So because I wondered if it's becomes interesting to people because they just think, let's quickly do a test with PG Bench, and wow, synchronous commit. What's that?
Have you tried PG Bench and turn off synchronous commit? I tried many times because it's obvious idea, and I don't remember I saw a huge advantage. Because PG Bench write transactions by default, they are not so simple. It's as I remember, it's update plus 2 inserts, maybe a delete as well. it's multi-statement transaction, which is definitely not super lightweight. Right. So
yeah, fair enough. I didn't try it.
yeah. Well, I can imagine we can have situations when the effect is quite noticeable, like dozens percent, like. But in general, from my practice, I stopped looking in this direction.
Yeah, fair enough.
To think about and of course, data loss is not a good idea. So I don't know, like write heavy workloads, maybe yes, but again, batching and all proper tricks to reduce number of actual commits happening, and that's it.
Yeah. And I think when people talk about data loss, they quite often immediately jump to things like banking apps, things where it's like absolutely critical not to, you'd much rather have some downtime than have some data loss. But I also think user experience wise, like even for just regular CRUD apps, losing data can be really confusing to people, even if it's only a not that important thing. The cases I was thinking of are much more like the time series ones, where if we've got one sensor reporting every minute, if we lose 1 minute if we lose a couple of those sensor reports, it's not that important. We can still do a bunch of aggregates on that data. So I guess like for monitoring and logging type things, maybe it's less important. But there can be really important logs too, right? Like, so I personally I don't see too many use cases where this makes a lot of sense. But there is a whole page on the Postgres docs about it's called asynchronous commit. So it must have been like somewhat of interest to quite a lot of people.
Right. Yeah.
Should we switch to the topic it feels like this gets more interesting when we start talking about having synchronous.
Let's do it. Let's move on and remote apply. First of all, own is overloaded when you have synchronous byte names non-empty. Synchronous by names non-empty, right? We can have purely synchronous replication, or we can have so-called quorum commit. And I just had a chat with one of our team members, and I agree. Like I heard criticism as well. Like quorum commit is very misleading term here, because usually it's used like this. Like we have multiple standbys. They are like synchronous originally by nature, but then we say synchronous commit, for example, remote write, and then we configure Postgres to allow synchronous standby names to have any, right? We say any, and for example, we have say 5 replicas, 5 standbys, and we say any one, right? Any one of them, and it means that commit happens on the primary and on any one additionally, so on 2 nodes before a user receives success of commit. It means 2 out of 6. 5 standbys, primary, 6 nodes. So 2 out of 6 is not quorum, because quorum definition of quorum means like more than 50.
So what that would be 4 out of 6.
Usually. I think we can like say this. In this case, it's the criticism like is conditional, right? We may say, okay, in our case, quorum definition is kind of rewritten, and we need 2 out of 6. But it sounds strange a little bit. So maybe how should we call this situation when we not just one synchronous replica and every commit must happen on both, but we have multiple replicas and we say 1 more or 2 more. So how do we call it? Semi-synchronous? I've heard this term as well. Semi-synchronous.
Yeah. I kind of like it. It does imply. Yeah.
But official doc says
it's confusing. Semi-synchronous is confusing enough that it means I have to look it up, which is probably helpful. I don't assume I know what it means.
Right.
But yeah, it doesn't fit into either category. Like it's not synchronous and it's not asynchronous. Like it's I don't like it though. I don't feel comfortable with it, because what's it saving us? Like, what's the benefit of is the idea that if both crash at the same time?
Yeah, before we talk about it, let's finish with terminology. I'm looking up right now the meaning of word quorum. Maybe it's not that bad, because in some cases we can say, okay, 25% is our quorum, right? We can define these rules. So like expectation that it should be more than 50, maybe it's like false expectation. So
Okay.
yeah. Anyway, but you cannot say percentage. You say like any one or two, right? Configuring Postgres synchronous standby names, you can say any word and then say you can have some kind of, it's an interesting syntax. You saw it, right? So
yeah, I also saw you could do, is it like priority?
Yeah.
Or yeah.
So yeah, there are some interesting things there, but anyway, idea is they work together, synchronous standby names and synchronous commit in this case. And if synchronous standby names is not non-empty, so there is like this magic happening. If it's just hostname, purely synchronous replication, right? But also purely synchronous, there are flavors we will discuss based on synchronous commit setting. If there is like expression is there, like any or like first blah blah blah, then it's already more complicated. But it's interesting, and official documentation mentions it uses the term quorum commit, right?
I saw it in a Crunchy data blog post. I didn't actually see it in the documentation.
Okay, doesn't matter.
Maybe
doesn't matter.
Yeah.
Let's talk about flavors. Let's consider we have only for simplicity just one hostname mentioned in synchronous standby names. No expressions, just one. And if we don't change synchronous commit setting, default is on. Here the meaning changes, right? Which like this makes me. I started with this, right? Like overloaded. The meaning changes, and what does it mean? It means that we need to wait until what? Like let's think.
So yeah, I think it's worth thinking about them in turn. I like to think of them like progressively. I think the order goes remote apply is the strongest. Okay. So remote apply will wait until it's not only been written to the write ahead log and flushed
to disk, but also
on the but available to queries. So read queries on the standby will be able to.
And here I think okay, apply here, but why replay there? In pgstat replication, it's called replay LSN, right? Okay.
Mm-hmm.
Apply or replay. Apply replay we consider the same thing, right?
Yeah.
Right. So
that's the strongest. I think that's the highest level we can set, and but it has additional latency, obviously. I think on is the next strongest. I think we wait for flush, but not for, what did you want to call it? Replay.
Replay or apply. Synonymous. So
and then there's one level below on, which is the write.
There is no remote receive. There is replay write.
Yeah, but I think receive is they're saying it's the same as write.
All data received transmitted over network received, but not yet flushed to file, but received, right? Yeah, write and receive.
Yeah,
write and receive are the same. Like there is a confusion because in different parts of Postgres here we have different words, different verbs used, right? But I agree, yeah. So there is a write, there is flush, and there is apply phases, and there are three steps here, and there is no remote flush, which I think overloading happens, but at least it would be good to have remote flush and say on is acting like flush, but there is no remote flush. There is also only remote write and remote apply. And instead of flush, we have on. Saving on number of words, right? To support it.
Number of settings.
Yeah.
But they did add a local, which I think, according to the documentation, they're saying is only for completeness. So it's interesting that
it's not only for completeness, and we will go there in a few minutes. Okay. So on means remote flush. medium setting, right? The wall is written like it's happening on the primary. In primary, we at commit time it's flushed to disk. We know that in the case of crash, it's already this wall data is already on disk. But what will happen with data pages during recovery? They will need to be adjusted, right? So like it's not applied yet, right? Good. So how do you feel about this? It's like synchronous replication, which means that if we lose the primary, the new primary will have everything, which is great, right? It will have everything, and it will be needed to be applied, so recovery, but we don't lose anything. It's great. Agreed?
Yeah, with a little bit of latency cost on each write?
Little bit.
Or a lot?
Yeah, this latency depends on the network as well, a lot.
Of course.
And usually we prefer to move standbys to different availability zone. And this increases latency, of course, and this means that if we keep this as is, like synchronous commit on and synchronous standby names this setting has one hostname, it means that we will have significant latency overhead. Right? This is why it's hard to use in heavily loaded projects, OLTP-like projects. But it's quite strict mode, right?
Yeah, and you can have an HA setup that's like within the same availability zone, or at least the same region. I'm guessing would massively reduce that.
Well, I wouldn't put. So for me, one availability zone can disappear. If you think about HA, we need to have a replica in different availability zone. Which, of course, there is trade-off here. We need to wait, right? Wait, like what is here, and then what's worse, what's best for us. And we move, for me, like HA means replica should be in different AZ. It's in different AZ, means like commit in this strict mode, remote flush or on, there is no remote flush. It means we will need to wait both synchronization with disk on the primary and there. And network will add overhead here. And I expect we won't be able to scale these writes very well. So if it's like thousands of writes per second, it will be noticeable issue. That's why in most cases I see people go to, well, by the way, remote apply, interesting. It's even worse. Like we need to apply this. Right? It's even worse, and it kills performance even more, right? What do you think about this mode? It's like extreme.
I actually lost you. I think our network connection.
Okay. When I discussed network issues, we had network issues. So I moved us to consideration of remote apply.
Well, yeah. So actually, question here then. This is no longer, I don't think, about risk of data loss, because if we've flushed, then we're good. So this is about. So is this for read replicas? This only makes sense if we're sending read traffic. Okay, great.
So this is good in terms of how data is visible there. We know, like by default on, it's like acting like remote flush, which again doesn't exist. Changes are not applied, so any reading session, which can be possible, the only possible option we can have only selects, like reads on standby. In this case, it won't see this data yet, right? And
unless we're using remote apply, in which case it would always be there.
It will be there right after commit. It's visible. It's great. So the delay between it's like written and visible becomes 0. Once it's committed, it's immediately visible. Great.
Yeah.
And when do we need this? Question is, when do we need, like, I don't know. I don't work with such projects. so I'm
right, because by the point you need read replicas, you've got the point of having read replicas is because you have so much read traffic that your primary can't serve it all, right? So we're talking about at least extremely high reads, maybe cases where we have a ton more reads than writes, and write latency is not that. Maybe social media again.
Yeah. In this case, this replica can be in the same availability zone because it's not for HA purposes, right? It's just to redistribute reads, maybe. I honestly don't know. We already have mechanisms everywhere implemented to deal with lags of replication. Like to stick to the primary right after writes and in the same session of user, like for some time, or like these kinds of things, right? So
you mentioned sticky reads before. I think you called them.
In this case, to slow down commits for the sake of this, like to reduction of this delay of this lag, I don't know. I would prefer to deal with small lags, but don't slow down commits.
Yeah. So I guess that's remote apply, and the default is on. Do you see use cases for remote write?
Remote write is the most popular.
Oh, really? Interesting.
Of course, most setups where synchronous standby names is non-empty, I see they use remote apply, most of them. Remote write.
Right, that makes more sense.
So the list complete, right? So, and here we have issues because this is super popular option. And by the way, I wanted to mention that yesterday on Hacker News it was the article from Afir, right?
Jepsen.
Yeah, Jepsen.
Yeah, Afir. Yeah.
It was discussing RDS multi-AZ clusters, which interesting. Like it's closer to our topic today, but to understand the article you need time, right? And so we have remote write as being very popular. What does it mean? The standby node received wall data, but hasn't flushed it yet to the disk. It means that if all nodes suddenly shut down, only primary will have this data. After commit, we know primary. If commit happens, primary flushed it, right? We don't have settings which say let us control the behavior of commit on standby nodes, but on the primary it's not flushed. Like if we have remote write on or remote apply, it means in any of these cases disk on the primary has wall data from this transaction, right? So it's not off at all already. It's not off. And imagine all nodes disappeared, only the primary has this data because standby, since it's remote write, is not guaranteed. Disk might miss this data, and this transaction might be lost. And this is okay. But in case we lose the primary completely, we lose data. Right? We lose data here.
Yeah.
But we lose data only if all nodes are shut down. Usually when we use the primary, standby nodes are not shut down. Unless something like
Yeah.
So let's say
bigger issue.
Let's say the loss of primary is our corner case, edge case. But loss of primary and standby nodes are not lost but shut down. It's kind of already a very corner case. So several edges, so several problems simultaneously. So usually they're still running. That's why remote write is so popular, because it says, okay, we lost the primary, we need to perform auto failover or manual failover, usually auto failover, and standby one or two, or how many you configure, of those standby nodes pair the setting, pair standby commit equals remote write, they have it in memory. And they're still running, so they will flush it. So the risk is good here. I mean, risk is understood, like loss of primary and everyone is shut down suddenly, but it's so low, so we can accept it, right?
Got it.
And say it still feels like synchronous commit to me because I doubt when we lose primary, standby node which received but not yet flushed this wall data, it will be suddenly off. It will be running, right? And we don't lose this data. This is great. This is why it's so popular. But it's great, except it's not, because if auto failover needs to happen, it's very rarely like sometimes people allocate like Crunchybeach or RDS not multi-AZ cluster but multi-AZ standby. Now there are two options. And multi-AZ standby means there is synchronous standby only serving HA purposes. You cannot send queries to it. Crunchybeach has the same, like not the same. They use Postgres replication to solve this. Exactly, they configure synchronous standby names, and they set synchronous setting to very weird, synchronous commit to very weird value. We will discuss it. But idea is HA replica doesn't receive traffic. It serves only for HA purposes. Great. But in many other cases, people use like, they say this quorum commit, one or two additional nodes must say data is received, remote write. And in this case, if we lose the primary, auto failover will happen to where? To one of these nodes which received, right? But the problem is, for example, if it's Patroni cannot choose this node because there is no such capability to find which, like we have 5 replicas, for example, 5 standbys. We know one of them received latest settings. How to find this node?
At least, yeah.
There is no such capability. Doesn't exist. Because this PG last receive LSN. PG last receive LSN. But it has the wrong name because it shows PG. It shows flush LSN. It's a bug. A bug or feature, I don't know. So this is a problem, and this is like if Patroni uses that, I think right now it uses that. It chooses the node which received which flushed LSN with maximum value, and this might be different node.
Yeah. So with that in mind, I guess it's then an acceptable risk, or that's why it has some data loss. But why not use on in that case?
Because it will slow down commits.
Okay, it's the trade-off.
We distribute our nodes among multiple AZs, availability zones, right? Yep. And there is network overhead.
Yeah, well, interestingly, I checked before coming on with our own Google Cloud SQL setup, and I wondered what our setting was, and it was on. So either they haven't. I'm pretty. But yeah, it's interesting that they could have chosen to set it to remote write.
And synchronous standby names is non-empty.
I didn't check. It's a good question.
If it's empty, you have pure asynchronous replication. This is it. This is it. Like I honestly, it concerns me a lot how overloaded values and names here. On means different things depending on different settings. Like why?
True.
Well, maybe we are trying to save on the number of configuration settings, GUC names, not to expand it too much. Okay, 300, but not. Let's not to expand it to 500, right? But this causes pain in brains, like people using this, right? So if it's on, okay. Is it?
No, you're right.
It's asynchronous.
No synchronous standby names.
Yeah. So it waits for flush only on the primary.
Yeah. So that's the same. That's basically just local.
Yeah. Good. So there's this problem. It's unsolved. It should be solved in Postgres. It should be solved in Postgres, and I think it's not super difficult to solve. So we need a function which will show write LSN or receive LSN or this right. By the way, receive and
Yep.
write maybe there are also a little bit different. You receive, but okay, doesn't matter because val receiver is a val receiver, right? Anyway, so a couple of more things deeper I wanted to mention. It's deeper things, but one of the things is even if we have a remote write, there is issue in the code that causes flushing periodically. So this like we have remote write, but sometimes we wait until it's flushed. And this is also like this. I guess this issue is known. It's revealed itself only under very heavy loads, and yeah, it also could be improved maybe, right? Because so remote write is not purely remote write. It's remote write, but at some point it's flush, and all transactions are currently being committed. They wait additional flush, and then it's again pure, like again write, then again flush, and it can be seen in the code that there are sinks there, fdata sync, right?
Roughly, yeah. I mean, is this also the will writer delay or a different kind of
it's
delay?
different. It's not documented.
Okay, interesting.
Yeah. So I mean, if you use remote write, there is like behavior which is not purely remote write. So it still involves disk sometimes, on like periodically. I guess some buffer is full and needs to be written.
Full, yeah.
And so on. But this causes delays of commits. Yeah, so
Makes sense.
Yeah, and another thing is probably off topic, but Crunchy Bridge. Like, let's discuss what we observed. And like, we just created fresh cluster and saw few things. One of them is synchronous standby names is filled with. Like, I created HA cluster.
Yeah.
So HA cluster was all good, and synchronous standby names has this host, which is HA replica. We can like it's not visible to us. We cannot send queries to it, and synchronous commit is set to local.
Yeah, so the first thing you mentioned, it being non-empty, means they're using Postgres replication, right? Like or what's the significance of that being non-empty?
If it's not empty, it's supposed to be.
Yeah.
If a synchronous commit was default on, it would mean we have a synchronous replication. Flush, as you said, like on means remote flush in this non-existing remote flush. It means, right? But it sets synchronous commit is set to local, which means we don't see the state of what's happening on standby. So, like commit only depends. The commit behavior depends only the primary.
Like my setup, right? Like on Google Cloud SQL for me, even though it's on, it's kind of like local because they're not using.
Right, but they still have
we
a
don't know.
replica.
Yeah.
Strange, right?
But local's confusing because I don't. Yeah, I would have, as you said, if I would have expected it to be on, or as you say, the more popular one.
If it would be on, if
Right.
it was on, this replica would be synchronous. If it's local, I guess it's asynchronous. Yeah.
Or asynchronous, yeah.
Asynchronous, right? Although it's mentioned in synchronous standby names.
Yeah, good point. What would you prefer it to like? Would you prefer it to be remote write, I guess, rather than on?
No. I think they are not like. I'm not sure it's mistake.
Well, it can't. It's not the default, right? So it's definitely deliberate.
There were some thoughts about this, I think, and I'm trying to guess what, because obviously making it synchronous would cause slow commits, right? Performance would be not great. Okay, we go to
so
local,
you think,
but why
like,
do
people are doing?
Yeah, we keep it local, so this HA replica becomes asynchronous. Huh.
Do you think it's to look good in benchmarking, or what's the like?
Why cannot we configure asynchronous replica in a normal way? Why should we put it to synchronous standby names, right? Because it could be regular asynchronous replica like present in slot, but not available for read-only transactions, right? So, but it's there. And the only idea, it's not my idea, we discussed this situation in the team, and idea came up into one great mind, was probably they want WAL to be written by backends, not by WAL writer, but because there's like this effect when you use synchronous by names, it's not empty, backends are writing. And this can increase throughput. It's a guess, hypothesis. If Crunchy is listening to us, and we know they're listening because they changed the random page cost to 1.1, right?
Oh yeah.
Actually, it's great. I also wanted to thank them because since then I stopped saying 1 and I say 1.1 because Crunchy benchmarked it and decided to use 1.1 for random page cost. Great, thank you so much. But if you guys are listening, please let us know what's happening with settings. It's really interesting. Maybe it should be documented because it's interesting. And so overall impression about synchronous commit, all those options and synchronous replication, I honestly see more asynchronous setups, purely asynchronous.
Yeah.
But I know serious guys, and I see clusters with synchronous, like quorum commit configured. My impression still there are things to be fixed and improved. This is cool. what I observe. And one more of, let's name it. When we created this cluster with HA, with HA checkbox, HA replica was also created. We see it in synchronous by names, and then we decided using our super user, which Crunchy has, and it's great. I think it's the only managed service, one of maybe two actually, which provides super user access, which is great. So we decided to change shared preload libraries, and restart. And there was idea: is this question? Is this change propagated to standby node or not? And what happened, Postgres restart, not cluster restart, Postgres restart, cost failover. This is not all right. This is not all right. Yeah. Freshly created cluster, and we did it 3 times. 2 out of 3 times failover happened. And another time it didn't happen. So I guess it's like some race condition is present there, right? And we saw that change was not propagated to a channel. So it's actually data loss if I have super user, it's my right? And I have alter system, it writes to, we can see it in PG settings and it's not yet applied, like pending restart is set to true, right? And then we have failover and we don't see it anymore. What is it? It's data loss.
Or it's unsupported behavior.
No, it's data loss. I wrote something using alter system. I wrote something and I lost it. Well,
so you can't have it both ways. That like I see where you're coming from 100%. But on one hand, you want super user access, and on the other hand, you're going to call it data loss if you change anything that doesn't get propagated.
Let me contradict with myself. Like I'm too harsh. I know. Like. Alter system is actually local. We can change settings on each standby separately, independently. So it's not guaranteed that it's not propagated by replication. I just expected maybe some automation exists which would propagate it. If this replica is HA replica, maybe we should match settings, because if this setting required restart, but what happens to settings that don't require restart? If I change them, and then what? Like if I change them using alter system, and do I lose them? This is not good, right?
Yeah. But equally, expectations of automations around this stuff is probably could be a nice excuse for other providers not to add super user access. So it's another.
No. Well, I think it's no.
I'm just saying, be careful what you wish for.
Well, it could be. It could happen. Like I change something using UI, and
No, because if you use the UI, they change it somewhere else that then does get propagated.
Maybe, but
Yeah,
I'm
for
rooting.
sure.
I'm rooting for Crunchy actually here. I think it can be solved, this problem. I don't want them to close super user access. It's a great feature, super great feature.
Good.
I think everyone should be, based on our previous week's topic, right? My position, RDS and others, they are taking too much from us. It stops feeling open source.
We don't need to make this point again, Nick.
Yeah, okay. Well, I'm going to repeat it many times, right? So it's not all right. So, and Crunchy are doing great job here to we are providing super user access, and I think it can be solved, right? And one more thing, if they are really listening, when I restart Postgres, I see restart cluster, right? It's like,
I feel like I need to chop this bit up and send it to them as a support thing.
Good? Yeah, it was good.
Nice one.
Thank you.
Yeah, thanks so much, Nikolay. And thanks for the request. And yeah, catch you next week.
See you. Bye-bye.